So today we're going to be completing notes number 4, and we're going to be transitioning from solving equations into solving linear inequalities. So before we get into solving inequalities, we're going to go through and give a few examples and also kind of define what certain symbols mean. So for inequalities, we could either have less than or equal to, greater than or equal to, less than or greater than. So here's our symbol for less than or equal to, or greater than or equal to, less than, and greater than. So an example using our less than or equal to, greater than or equal to would be something like x is less than or equal to 3. What that means is that x doesn't just equal 3, but x could be any value that's less than 3 or equal to. And so there's a few things that we need to know about how to use these symbols when we're identifying answers. And one way, a good way to show the answer of an inequality is using a number line, because the solution is no longer just one value. It's kind of has an end or start point, and then either all the values less than that or all the values greater than that. So on our number line, we could show this solution okay, so here's a number line 0, 1, 2, 3. Now, because it is less than or equal to, it means we want to include the value of 3 in our number set. Okay, so when I'm drawing in my graph to show that I'm including 3 in my number set, I used a closed dot at 3. And then when I look at my number line, the values that are less than 3 would be to the left. So I use an arrow to indicate that my solutions for this inequality include 3 and any value that is less than 3, any number over here. And this number line goes from negative infinity up to positive infinity. It keeps going in both directions. Similar if I have greater than or equal to. So if I have something like x is greater than or equal to -2, then I could draw that on a number line. And where -2 is, we want to include that solution. Okay, so I'm using a closed circle. And greater than, values that are greater than -2 would be to the right. Anytime I have less than or greater than, we are going to use a closed circle on our graph, okay, on our number line graph. We also have just less than or just greater than. So if I had x is less than -1, for example. Now, when I graph something that is just less than the given value, that means that x cannot equal -1. Okay, so -1 is not included in our answer set. Only values that are less than -1 would be included. So I'd have 0, -1, +1, and so on. To show that we're not including -1, when we graph less than or greater than, we use an open circle. So my graph would have an open circle at -1 and then going less than. Okay. I could also have x's, let's just say greater than 2. So on my number line, 1, 2, greater than 2, but not including 2. So I'm going to use an open circle at 2, meaning that's not a solution here, but any value greater than 2 over here would be a solution, okay? Now, before we do this interval notation stuff, I want to go down and kind of fill in some information about our inequalities. So first of all, we solve inequalities using inverse operations. Okay, just like we solve equations. So first, we'll clear any parentheses, just like always. Then we will collect any like terms. Okay, then we'll collect our variable to one side. And then from there, we will solve. Now, when we get to this piece, so when we're solving, first we add, subtract, and then we multiply, divide. Okay, so when I'm solving an inequality, we follow the same exact steps as when I'm solving an equation. When we get to this piece right here, there's something very special that we need to remember to do with our inequalities. And that's when we multiply or divide an inequality by a negative number, we need to flip our inequality sign. Okay, that's different than when we have an equation. So in order to keep our inequality solution true, we need to flip our sign if we multiply or divide by a negative number. So for example, if I had negative 4x is less than or equal to 12, when I go and divide by negative 4, that's going to flip my inequality sign around. So it was a less than or equal to is now a greater than or equal to, okay? Now I have greater than or equal to negative 3. So there's my solution. Another time that we flip our sign is we want to write our answer as variable, inequality symbol, and then a value. Okay, so that's the order that we want to write our final answer in. Okay, order matters for our final answer. So if I have something like this, 2 is less, or 2 is greater than x, that doesn't really make sense when I'm solving to say, well, 2 is greater than x. We want it to read the way we want our solution to read. So we want to flip this around and put x on the left-hand side like we do with our equations. And if I flip that, I need to also flip around my sign. Or another way to think about it is this inequality is pointing towards x here. When I flip it around, it still should be pointing towards x here. And the way that this reads is x is less than 2, which means x can be any value that's less than 2, but not including 2. Okay, so I do want you to always have your answer written in this way, where it's variable first, then the inequality symbol, and then the number. Okay, so if I flip sides, then I need to flip signs. Okay, so those are our basics with our inequalities. Now let's go back up and talk about interval notation. So interval notation is another way that we can show the number set that's being represented by our inequality solution. Okay, so interval notation is going to be a way to write all the values that x could possibly be. And so I'm just going to give us a number line and remind you that that number line goes on forever in both directions. So on the left-hand side of the number line, it's going towards negative infinity. And on the right-hand side of that number line, it's going towards positive infinity. So for my first example, where x is less than or equal to 3, the values that x could be go from, it could be any of these negative numbers. So negative infinity up to 3 and stopping at 3. Okay, so in the same order you read the graph, your interval notation would go in that order as well. So going from all negative infinity, okay, my answers go all the way down, up to 3. Now, with interval notation, we use parentheses and brackets to indicate if the answer is included in our solution set or if it's not. So by our infinity and negative infinity, we're always going to put parentheses. If we're including that value in our number set, we will put a bracket on that side. Okay, if we're not including it, we will use a parenthesis. So our infinity, negative infinity is always a parenthesis, okay, because there's really no endpoint there. It's just going on and on and on. And we want to include 3. So we're going to use a bracket to show that that solution set is all of our negative numbers up to 3 and including 3. So similar to how we said, well, less than or equal to, greater than or equal to is a closed circle, we're also going to put over here that for our interval notation, we would use a bracket, okay? So for our other example, x is greater than or equal to -2, the way that looking at my number line kind of helps me see this number set here. So my answers start at -2 and go up towards positive infinity, and it's always parenthesis around that infinity symbol. And because I'm including -2 in my answer, I'll indicate that that answer is included by using a bracket. On the next example we have here, x is less than -1. So less than -1, meaning all of my negative numbers up to -1. Parentheses around my infinity symbol. To show that we aren't including -1 in our answer, in the same way we use an open circle here, we show that differently for our interval notation. To show that that's not including -1 and only values less than that, we put a parenthesis next to -1. X is greater than 2, so my number set for my solution is 2, and then all going more positive infinity, parenthesis around the infinity symbol. We're not including 2 in our solution, so we include we show that that's not included by using parentheses in my interval notation. Okay, so open circle and parentheses for our interval notation. So let's look at a couple examples. So really a lot of this inequality stuff is going to feel the same as when we were solving equations. It's just that now you're going to be asked to show that solution, the number set that would be a valid solution for your variable in several different ways. So we're going to solve the inequality, then we're going to graph it, and we're going to write it in interval notation for each of our examples. So the solving piece shouldn't feel that unfamiliar. So if I want to isolate my variable here, I'm going to be adding 7 to both sides, and I get 5x is greater than 5. Be careful not to start writing equal signs just because you're used to doing that when you're solving. I've seen students do that before, and then they don't know what the correct inequality symbol should be at the end. So make sure you keep your symbol in each step going through. And then I'm going to divide by 5, and I get x is greater than 1. So there's the first part for my solution of my inequality. Now I'm going to graph that solution. So I'm going to draw a number line. Make sure your number line has some sort of scale. Don't just throw your solution down there and no sort of scale. So I have a number line here. Here's 0. This is where 1 is. It is not including 1. So that means I would have an open circle at 1. And it is values greater than 1. Values that are greater than 1 would be to the right. There's my number line. So in my solution, I'm representing that solution on a number line. So x can not equal 1, but be any value greater than 1 over here. And I'm also going to represent my solution using interval notation. So my interval notation would be 1 going towards positive infinity. And because I'm not including 1 in my solution, it's a parenthesis, and always parenthesis by the infinity symbol. Okay, so here's another way to represent my solution set. Let's go to 3. So first I'm subtracting 13 here. I have 4x is greater than or equal to -4. Dividing by 4 on both sides, x is greater than or equal to -1. Notice I divided, but I didn't flip the sign. I didn't flip the sign because my coefficient's not negative. Okay, so I only have to flip my inequality sign if the number in front of my variable is a negative number. If the number that I'm dividing by is a negative number. I'm going to take that solution and graph it on a number line. Again, give your number line some sort of scale. For this inequality, okay, so up here we knew that this was an open circle. This inequality should be a closed circle because its x is greater than or equal to. And here's -1. Closed circle at -1. Greater than would be going to the right. Okay, here's a representation of my solution set. So including -1 and all my values that are greater than -1. And I can also represent this with interval notation. So from -1 towards positive infinity, a bracket next to -1 because it is including -1 in the answers, in the answer set, okay? On 6, we have variables on both sides. So I don't have parentheses to clear. I don't have like terms to combine. I'm going to collect my variables to one side. I'm going to do that by subtracting 4x. You could have also subtracted 2x. So that gives me -2x subtract 4 is greater than or equal to -1. I'm adding 4 to both sides, so -2x is greater than or equal to 3. And I'm dividing by -2. So I'm dividing by a negative. I need to flip my sign. Okay, so greater than or equal to becomes less than or equal to, and this is -3/2 or -1.5. I can represent my solution on a number line. -3/2 would be between -1 and -2. Close circle because of the inequality that I have, and then I'm going less than, so I'm going to the left with my arrow. I can also represent this using interval notation, and so this time it's less than, so my answer, my number set here that would be a solution for x would be all my negative numbers, so -infinity up to -3/2 and including -3/2. On 8, I don't have parentheses to clear. I don't have variables on both sides. I'm just going to solve. Subtract 2, -4x is less than or equal to -24. Divide by -4. I'm dividing by a negative, so I need to flip my sign. And it would give me x is greater than or equal to 6. On my number line, again, give your number line some sort of scale. 6 in, it's including 6 because of the type of inequality that I have. And because I flipped my sign, it should be going to the right for greater than. And my number set is including 6 towards positive infinity. Last example on this left-hand side, I have parentheses, so I'm going to start by clearing my parentheses first, which would give me 6 subtract 24n subtract 28 is greater than or equal to 122. I have like terms that I need to combine, careful here, so at +6, and I'm taking away 28, so I'm at -22. Subtract 24n is greater than or equal to 122. And now I add 22 to both sides. And I have -24n is greater than or equal to 144. And again, because I'm dividing by a negative number, I need to know to flip my sign. When I divide by -24, flip my sign, now n is less than or equal to, and 144 divided by 24 gives me 6. Positive divided by negative gives me -6. And now representing that solution on a number line. 1, 2, 3, 4, 5, 6. Here's -6, including -6, so closed circle. Going less than, so going to the left. There's my solution graphed on a number line. Written in interval notation, going from -infinity up to -6 and including -6. So bracket by -6. So now what I would like for you to do is complete the 5 problems on the right-hand side of the paper and then check your work by continuing the video. Okay, so now we're going to check our work. I didn't complete all of them because as I was working through a few, I thought it would be worth finishing them up together. So on my first problem, you should have gotten x is less than or equal to 2. Here's the graph for that. Interval notation here would be my number set would go from negative infinity up to 2 and including 2. There's my interval notation. On number 4, you get x is less than 3, open circle, going less than, and interval notation would be from negative infinity up to 3. Notice here's a bracket because it's including 2. Here's a parenthesis because it's not including 3. I stopped on 7 because I thought some of you might be confused here. So I subtract 3. Then to undo this here, the opposite of dividing by 2 would be to multiply by 2. So I'm going to be multiplying by negative 2 here on both sides. I flip my sign if I multiply or divide by negative. So because I'm multiplying by a negative, you should flip your sign here. Gives you y is greater than 6. So on a number line, you should have an open circle at 6 and greater than because you flipped your sign, so going to the right. Interval notation would be 6, not including 6, to infinity. On 9, combine like terms, you get negative 5p. Divide by negative 5. When I divide by a negative, I flip my sign. So make sure you're flipping signs on 7 and 9. That open circle going less than 2, interval notation would be from negative infinity up to 2, not including 2. And I stopped myself on the last one. So I had distributed and then I subtracted 20 from both sides. At this point, I'm going to divide by negative 49. Now this one's a little tricky. So I'm dividing by a negative. This gives me negative 3. Because I'm dividing by a negative, I should be flipping my sign. Okay, but on this one, my variable is on the right-hand side, and I want my variable on the left-hand side. So I'm going to rewrite this, and I'm going to flip-flop my sides. And if I flip-flop my sides, I need to flip my sign so that it still reads the same way. So notice again, my inequality is pointing towards R here. It still needs to point towards R. So we did like a flip and then a flip again. So on my graph, negative 3, open circle, going less than, interval notation would be from negative infinity to negative 3, not including negative 3. Okay, so now you will have some homework on inequalities tomorrow in class. That will give you some more practice. Probably the trickiest piece here, right, is graphing it correctly and writing the correct interval notation. You really, really, really want to be aware of when you flip your sign, because if you notice, if you didn't flip your sign, not only is your answer wrong, but your graph would be wrong and your interval notation would be wrong.